We need to find the 6 trig functions of theta equals 5 pi over 6. We'll start by labeling a diagram in order to help us visualize this problem better. So we'll draw the unit circle, and our angle 5 pi over 6 is in quadrant 2, approximately here. So this represents theta, and 5 pi over 6 is represented by that angle. And then our reference angle is formed between the x-axis and the terminal side of the angle. So theta prime, or our reference angle, would be here. We can go ahead and draw our right triangle, a little right angle sign there. And now we can determine the reference angle. The reference angle is going to be pi minus 5 pi over 6. We're going to use a common denominator of 6, so 6 pi over 6 minus 5 pi over 6 equals pi over 6. So pi over 6 is our reference angle. Now, when we evaluate the sine of 5 pi over 6, we can evaluate it using our reference angle pi over 6. In degrees, that's 30 degrees. So we can label our diagram. The opposite side of 30 degrees, or pi over 6, is a positive 1/2 in quadrant 2, because the y value is positive in quadrant 2. And our adjacent side, or x-coordinate, is negative in quadrant 2, and the adjacent side of 30 degrees is a negative square root of 3 over 2. Now we can easily find all of our 6 trigonometric functions. The sine of 5 pi over 6 equals the opposite angle 1/2 over the hypotenuse 1. Go ahead and label that hypotenuse 1, which simplifies to 1/2. The cosecant of 5 pi over 6 is equal to our hypotenuse 1 over the opposite side 1/2, which simplifies to 2. Another way of thinking of this is the cosecant of 5 pi over 6 is equal to 1 over the sine of 5 pi over 6, which is our y-coordinate 1/2. Next, we have the cosine of 5 pi over 6, which equals our adjacent side, negative square root of 3 over 2, over our hypotenuse 1, which simplifies to negative square root of 3 over 2. Next, we have the secant of 5 pi over 6, which is equal to our hypotenuse 1 over the adjacent side, negative square root of 3 over 2. Again, you could think of the secant of 5 pi over 6 as 1 over the cosine of 5 pi over 6. And the cosine of 5 pi over 6 was negative square root of 3 over 2. In order to simplify this, we need to multiply by the inverse of the denominator. So 1 times negative 2 over the square root of 3, which is here. And to get rid of the radical, we need to rationalize the denominator by multiplying the numerator and the denominator by the square root of 3 over the square root of 3. And we get negative 2 times the square root of 3 over 3. Now we have the tangent. The tangent of 5 pi over 6 equals our opposite side, positive 1/2, over the adjacent side, negative square root of 3 over 2. So we have 1/2 times the inverse of the denominator, 2 over the square root of 3. And we have a negative 2 over 2 times the square root of 3. The 2's cancel. We're left with negative 1 over the square root of 3. Rationalize the denominator, and we get negative square root of 3 over 3. And lastly, we have the cotangent, which equals the adjacent side, negative square root of 3 over 2, over the opposite side, positive 1/2. That simplifies to negative square root of 3 over 2 times the inverse of the denominator, 2 over 1, equals 2 times the square root of 3 over 2. The 2's cancel, and we're left with negative square root of 3. Next, we're going to find the 6 trigonometric functions of when theta equals negative 2 pi over 3. Now, first, we need to recognize that we have a negative angle, and we prefer to always work with a positive angle, particularly an angle between 0 and 2 pi radians if we're working in radians, or 0 and 360 degrees if we're working in degrees. So in order to find our coterminal angle, let's go ahead and add 2 pi. So we'll start with negative 2 pi over 3, our given angle, and we'll add 2 pi. Using a common denominator of 3, we have negative 2 pi over 3 plus 6 pi over 3 equals a positive 4 pi over 3. At this point, we could go ahead and make a diagram to help us visualize this a little bit. So we'll start again with our unit circle down here. And 4 pi over 3 would be approximately here. And we can go ahead and label this theta. So we're evaluating this angle here. That's 4 pi over 3. Our reference angle is going to be the difference between the terminal side of the angle, which is here, and the x-axis. So we can find that by taking our angle 4 pi over 3 and subtracting pi. Using a common denominator of 3, we have 4 pi over 3 minus 3 pi over 3, which equals pi over 3. So our reference angle, theta prime, here, equals pi over 3, or in degrees, 60 degrees. We can go ahead and draw our right triangle, recognizing that we're working in the third quadrant here. And since our reference angle is pi over 3, or 60 degrees, we know that the opposite side of 60 degrees is the square root of 3 over 2. And because we're in quadrant 3, it's negative. The adjacent side of pi over 3 is 1/2. Again, because we're working in quadrant 3, it's negative, because the x-coordinate is negative in quadrant 3. Now we can go ahead and find our 6 trigonometric functions. So we're asked for the sine of negative 2 pi over 3. Again, using our reference angle of pi over 3, the sine is equal to opposite, which is the negative square root of 3 over 2, over our hypotenuse 1. I'll go ahead and label the hypotenuse on the triangle 1. And we get negative square root of 3 over 2. The cosecant of negative 2 pi over 3 equals our hypotenuse 1 over the opposite side, negative square root of 3 over 2. So we'll multiply by the inverse of the denominator, and the result will be 2 over the square root of 3. Rationalize the denominator by multiplying the top and bottom by square root of 3. And we get 2 times the square root of 3 over 3, and that's negative. Next, we have the cosine of negative 2 pi over 3, which equals our adjacent side, negative 1/2, over our hypotenuse, 1, which simplifies to negative 1/2. The secant of negative 2 pi over 3 equals our hypotenuse over our adjacent side, negative 1/2, which simplifies to negative 2. Next, we have the tangent of negative 2 pi over 3 equals the opposite side, negative square root of 3 over 2, over the adjacent side, negative 1/2. The negatives cancel, and we're left with a positive square root of 3 over 2 times the inverse of the denominator, 2 over 1, and we get 2 times the square root of 3 over 2. 2's cancel, we're left with the square root of 3. And finally, the cotangent equals the adjacent side, negative 1/2, over the opposite side, negative square root of 3 over 2. Again, the negatives cancel, we're left with 1/2 times the inverse of the denominator, 2 over the square root of 3. 2's cancel. Well, actually, we'll multiply across first. 1 times 2 is 2. 2 times the square root of 3. Now our 2's cancel. We're left with 1 over the square root of 3. Multiply by square root of 3 over the square root of 3 to rationalize the denominator, and we have the square root of 3 over 3. Now go ahead and pause the video and try these problems on your own. I'll scroll down just a little bit so you can see all of the problems. Notice that theta equals negative 5 pi over 4. Again, we prefer to work with positive angles between 0 and 2 pi, so we're going to go ahead and find a coterminal angle that's equivalent. So we'll start with negative 5 pi over 4. And we're going to add 2 pi. That's equal to negative 5 pi over 4, plus, using a common denominator, we'll do 8 pi over 4, which is equivalent to 2 pi. Then we'll add the numerators. Negative 5 pi plus 8 pi is 3 pi over 4. So 3 pi over 4 is our coterminal angle. At this point, we can go ahead and draw a diagram to help us visualize this problem better. So we'll start with drawing the unit circle. And 3 pi over 4 would be approximately here. So angle theta is here. This distance here. We're going to be evaluating our reference angle, which is between the x-axis and the terminal side of our angle. So theta prime, our reference angle, is here. We can go ahead and draw our right triangle. And now let's go ahead and determine our reference angle. Our reference angle is going to be pi minus 3 pi over 4, the terminal side of our angle. We're going to use a common denominator of 4, so we'll have 4 pi over 4 minus 3 pi over 4 equals pi over 4. So our reference angle equals pi over 4, or equivalently 45 degrees. Now we can go ahead and label our triangle. We always have a hypotenuse of 1 because we're dealing with the unit circle with a radius of 1. The opposite side of 45 degrees is square root of 2 over 2. It's going to be a positive square root of 2 over 2 since we're working in the second quadrant and the y values are positive in the second quadrant. The adjacent side of 45 degrees is square root of 2 over 2. But because we're working in the second quadrant where x values are negative, it's going to be a negative square root of 2 over 2. Now we can go find our 6 trigonometric functions. So sine of negative 5 pi over 4 using pi over 4 as our reference angle is the opposite side, positive square root of 2 over our hypotenuse of 1 simplifies to the square root of 2 over 2. The cosecant equals the hypotenuse 1 over the opposite side, square root of 2 over 2. We're going to multiply by the inverse of the denominator, so we'll have 2 over the square root of 2, 2 over the square root of 2. Rationalize the denominator by multiplying the top and bottom by the square root of 2. So we have 2 times the square root of 2 over 2. The 2's cancel, and we're left with the square root of 2. The cosine of negative 5 pi over 4, using pi over 4 as our reference angle in the second quadrant, is the adjacent side, negative square root of 2 over 2, over our hypotenuse of 1, which simplifies to negative square root of 2 over 2. The secant of negative 5 pi over 4 is our hypotenuse, 1, over the adjacent side, negative square root of 2 over 2. We'll multiply by the inverse of the denominator, so 1 times 2 over the square root of 2 negative, which equals negative 2 over the square root of 2. Rationalize the denominator by multiplying the top and bottom by square root of 2, and we get negative 2 times the square root of 2 over 2. The 2's cancel, and we're left with negative square root of 2. Next, we have the tangent of negative 5 pi over 4 equals our opposite side, positive square root of 2 over 2, over our adjacent side, negative square root of 2 over 2, which simplifies to negative 1. The cotangent of negative 5 pi over 4 equals our adjacent side, negative square root of 2 over 2, over our opposite side, positive square root of 2 over 2, which simplifies to negative 1.